Question number 10. So we are going to calculate expected value and the standard deviation. So in this case, let's use Excel. Okay, so we have different X values or the dollar amount for the finance charge. So the first value is $10. The second one is $20. The third value, the third possible value is $30. Okay, then let's get the corresponding probability. For $10, the probability is 20%, 0.2. For $20, the possibility is 25, 50%, and for $30, that's going to be 30%. Okay, then let's calculate the expected value first. Okay, the expected value is to add up all the product between the corresponding X value and the probability. So let's do this. So it's equal to the first X value times the corresponding probability plus the second X value times the corresponding probability plus the third possible value times the corresponding probability. Okay, then we get the expected value and standard deviation. So before calculating the standard deviation, let's calculate the variance. We know standard deviation is just the square root of variance. Okay, so let's calculate the variance first. So it's equal to the difference between the X value and the expected value. And then we need to square it and times the corresponding probability. Okay, then plus the difference between the second X value and the expected value. And then we have to square the difference again and times the corresponding probability, 0.5. Okay, then plus the third one, the difference between the third value and the expected value. We have to square it. Then we times the corresponding probability. Okay, then that's a variance. And this question is asking for standard deviation. So let's just take the square root of the variance. So that's going to be square root of this variance. So we got the standard deviation. Okay, so that's question number 10. So question number 11. So a manager at a company that manufactures cell phones has noticed that the number of faulty cell phones in the production run of cell phones is usually small, and that quality of one day's run seems to have no bearing on the next day. So which model should we use to model the number of faulty cell phones produced on one day? Okay. So it's talking about faulty cell phones to be produced, or in other words, faulty cell phones are arriving. Okay. So in the chapter 6, we learned a distribution called Poisson distribution to model arrivals. It can be customers' arrivals or order arrivals. It could be about faulty cell phones arrival. Okay, so this is a Poisson model we need to use. Then let's calculate some probability. The probability that no faulty cell phones will be produced tomorrow. Okay, so in one day we don't have any faulty cell phones, and what are the information? What is the information given to us? If the mean number of faulty cell phones is 3.2 per day, we are going to calculate this probability. Okay, so let's go to the StatCrunch. Okay, so stat calculators, and we're talking about the Poisson distribution. So let's click this Poisson. Okay. All right. So we need the mean. So what is the mean? The mean is here. So the mean number of 47 is 3.2. So let's put 3.2 there. And we want to calculate the probability that no 47s. So 0 47s. So the probability that the number of 47s is equal to 0. Okay. So that's the one we want to calculate. So part B, this is, then part C, what's the probability that 3 or more 40 cell phones will be produced? Still, the mean value is 3.2, so we don't have to change this one. But the probability is different. We want to calculate the number of 40 cell phones is 3 or more than 3. 3 or more than 3, that means greater than or equal to 3. So let's do this compute. Then that's the answer.